this lesson, we're going to use logs to solve exponential equations. Let's look at the one-to-one properties. If we have a to the x is equal to a to the y, this is true if and only if x is equal to y. Seems logical. So if our bases are the same, well, then the exponents must be equal to one another here. Similarly, we have one for log. So log base a of x is equal to log base a of y if and only if x is the same as y. And then a reminder of our inverse properties. So if we have an exponent to a log of the same base, it produces just the argument of x. They undo each other. They're inverses. And vice versa, log base a of a to the x is also equal to x. These properties are going to be very useful as we go through some examples solving, first of all, exponential equations, but using logs to solve them. So for the first one, I have 4 to the x plus 2 is equal to 16 to the x minus 3. Well, one of the tips when you have one like this with a numeric base, if possible, make your bases equal to one another. If you can, then you can use a one-to-one property to solve it. So here's how I'm going to do that. I'm going to rewrite 16 as 4 to the second power, and then it's still raised to the x minus 3, so what I have here is a power to the power, so I'm going to multiply my exponents together. So that's going to produce 4 to the 2x minus 6, and that's equal to 4 to the x plus 2. Now, because my bases are the same, my one-to-one property, I know that my exponents have to be equal to each other. So x plus 2 has to equal 2x minus 6, and now I have nothing more than equation in one variable. So I'm going to bring my 2x to the left, so I'll have negative x is equal to, subtract 2 from each side is equal to negative 8, and divide by negative 1, and I get that x is equal to 8. And I quickly check to make sure that this is true, so I would have 4 to the 10th. Is that equal to 16 to the 8 minus 3 would be 5. If you toss that in your calculator, you'll see that it is, so our solution works. My next one, I have 1/3 as a base and 1 over 81. Now, first of all, whenever I have a fraction, my go-to thing is to change it back using a negative exponent. Making this be 3 would be to the negative first, so I would have to the negative nth power. And 1 over 81 could be 1 over 3 to the 4th, and I still have to the 2/3. And then I could make this 3 to the negative 4th to the 2/3, which is power to power would be 3 to the negative 8/3. So now my bases are the same, so I can use my one-to-one property where negative n is equal to negative 8/3. Therefore, n is equal to positive 8/3. I'm going to just check and make sure that my solution is correct. So 1/3 to the 8/3, throw that in my calculator, I get approximately 0.0534. Toss 1 over 81 to the 2/3 in my calculator, and sure enough, I get the same decimal. So my solution is correct. Okay, now, sometimes we do not have a scenario where we can make our bases be equal to one another. There's nothing I can do here to make 3 and 7 be the same. So the key to solving this is to take the log of both sides. Whatever I do to one side, I've got to do to the other. So I'm going to take the log of both sides in order to get the variable out of the exponent spot. Now, I could take any log base that I want. I could do the common log or the natural log. I'm going to do the common log here. So this would be log of 3 to the x power is equal to the log of 7. Okay. Now I'm going to use my log properties. So I have an exponent here, and think log of 3 is an exponent, so an exponent to an exponent is your power rule. So I'm going to bring this x out front, will be x times log of 3 is equal to log of 7. Now, I want to remind you that log of 7 and log of 3 are just numbers. So I have my variable out of the exponent spot. So what I'm going to do is I'm going to divide both sides by the log of 3. Okay? So x is equal to the log of 7 divided by the log of 3. So this can just be typed into your calculator as you see it. So when I do that, I get that x is approximately 1.77. Now you should do a check to make sure you don't have any extraneous answers. So when I have 3 to the 1.77, and I actually just leave the previous answer on my screen. So what I actually type in is 3 to the answer power, and I get exactly 7. All right, let's try another one here. I have e to the 2x plus 1 is equal to 8. So no way to make these bases be equal to one another. So I am going to take a log of both sides, and I'm going to choose to take the ln of both sides because the ln is a log with a base of e. All right, now again, I'm going to use my power rule, which means I'm going to bring this 2x plus 1 out to the front. So I would have 2x plus 1 times the ln of e is equal to the ln of 8. Now, the ln of e, this is inverse. This is actually 1. You just need a little reminder, the ln is a log with a base of e. So if I'm saying e to what power is equal to e, is what this is really saying, well, that's e to the first. So the ln of e is 1. So then what I actually have is 2x plus 1 times 1 is 2x plus 1 equals the ln of 8. So what am I going to do? I'm going to isolate x by subtracting 1 and dividing by 2. So x is equal to the ln of 8 minus 1 all over 2. And this you can type into your calculator. When I do, I get x is approximately 0.54 to the nearest hundredth. And then I quickly do a check. I type into my calculator e to the 2 times my previous answer, which was the 0.54 plus 1, and sure enough, I get that it equals 8. So my next one, I have 4 to the 3x minus 1 is equal to 3 to the 2 minus x. So first I check, can I make 4 and 3 have the same base? Nope. So I'm going to go and take the log of both sides. I can do the log or the ln. I'm actually going to choose to take the ln again, just because, well, frankly, it takes 2 letters of writing as opposed to 3, which is a good reason as any. Ln of 3 to the 2 minus x. Okay, so now I'm going to use my power rule and bring this out front, which gives me 3x minus 1 times the ln of 4 is equal to 2 minus x times the ln of 3. And just looking ahead here, sometimes the roadmap is not completely clear, but I recognize that I have an x on either side and it's embedded within parentheses. I need to get my x's on one side and my constants to the opposite. So I'm actually going to do some distributing on both the left and the right. So I'm going to distribute the ln of 4 to both, which gives me 3x times the ln of 4 minus the ln of 4 is equal to, now I'm going to distribute the ln of 3, 2 times the ln of 3 minus x times the ln of 3. Right? So now my goal is to get everything with an x on the same side and my constants to the opposite. So my values with an x are highlighted in yellow and highlighted in blue would be my constants. So I'm going to take my constants to the right, so 2 times the ln of 3 stays where it's at, plus the ln of 4. And 3x times the ln of 4 will stay where it's at, and I will bring this one over, so plus x times the ln of 3. Okay, now since I have an x in both spots on the, or in both terms, I should say, on the left, I'm going to use some factoring. I'm going to factor out x, which leaves me with 3 times the ln of 4 plus the ln of 3 on the inside equals the same expression from above. So now what do I have? Everything here is numeric and this is numeric. So this is, a number. To get x by itself, if I divide both sides by this, that would give me x equals 2 times the ln of 3 plus the ln of 4 divided by 3 times the ln of 4 plus the ln of 3. Now, honestly, when you get it to this part, you actually could just type this in your calculator and get a decimal and round it to the nearest hundredth. I'm just going to continue it because I'm fascinated with the algebra part of this, how we can manipulate it by condensing to make this, even sweeter to put in the calculator, and it's great practice with your rules. So the top part would become the ln of 3 to the second times 4, which would be 9 times 4, or the ln of 36, over, now this denominator, bring the 3 up, would be the ln of 4 to the third. That addition would be times 3, since both of those ln's have the same base. So 4 to the third would be 64 times 3 would be 192. Now this one's even easier to type into a calculator, and that is approximately 0.68. Take a second and check your answer, and sure enough, it checks.